Each of the three types of plate movements are illustrated in one of these boxes here. The one over here on the right would be showcasing divergent plates, where we have arrows that are going in opposite directions, or in other words, separation occurring. I'm going to use very complex illustrations, sarcasm, to illustrate divergent plates. So we're going to have a plate that's going to be separating into two individual plates, which is clearly evident here, as the plates move further and further apart from each other. What is it that creates that separation? That's going to be the focus of the rest of this discussion. A simple way to visualize what causes this separation is if I have this wedge here, this orange wedge, if I hammer it from below, if I pound on it from below, what's going to happen is it's going to go up and, of course, cause separation to occur. A very simple way to illustrate kind of the basics of what happens in divergent plate boundaries. We go back to the plate boundary map and we can see in this box here the country of Iceland. The country of Iceland actually has separation occurring right through the middle of the country. And if we zoom into Iceland, we can see that actually the North American plate and the Eurasian plate are separating from each other. And so this ridge, this separation, this divergent plate boundary that occurs right through the middle of the Atlantic, actually we can see here when we look at an image. And so knowing that we're looking to the south here in Iceland, this bridge across this rift or across this valley in the southern part of Iceland, on the left-hand side essentially is the Eurasian or the European landmass. Over on the right-hand side is the North American landmass. I know this because we're looking to the south. Key to understanding a transform boundary, it's not divergence or separation like we looked at when we looked at Iceland. It's not what we're going to look at next when we look at convergent plates, where we have arrows that are going in, coming into each other. Instead, it's more like a highway in which you're driving on one side of the road, the person going the other direction's on the other side of the road, and so you're going in opposite directions. So key to understanding a transform boundary, it's not collision and it's not separation. To help visualize transform boundaries, we use once again our very complex illustrations, and so we're going to see a little bit of landform change along this fault boundary, but we're not going to see the massive landform features created in the other two types of plate boundaries. Here in our illustration, the plates are now going to start sliding by each other, illustrating a transform fault, and more specifically a strike-slip fault, as the pink plate slowly slides by the stationary yellow plate. Here's our transform fault boundary, the San Andreas Fault. We can see on one side of the San Andreas Fault is Los Angeles, and on the other side is San Francisco. So one of the things you'll note is the arrows indicate the direction that the plates are moving. This is kind of hard to fathom, but over time, Los Angeles will actually move, this will be once again way after we're gone, move further north than San Francisco, and so eventually Los Angeles will be north of San Francisco as this plate continues to move to the north, whereas the other one, the North American plate, relatively moves to the south. There in the Caribbean is the country of Haiti, which has had a series of natural disasters that has definitely wreaked its havoc here. One of the natural disasters has been a recent earthquake that has occurred right here along a transform fault boundary that goes right through the middle of the country. This is even more problematic because most of the people in Haiti live right there along that fault boundary. And so one thing to note is these do cause death and destruction. Although they're not big landform changers, they're not big landform creators, they definitely, with the form of earthquakes, can do their damage. Our third and final tectonic plate boundary is convergent plates, which we can describe very simply using our plates. This is going to be from the side view of two plates that are going to be converging and colliding with each other as the pink plate moves closer to the stationary yellow plate. Moving closer. Collision. And of course, with this collision, something's got to give. And so in this case, the pink plate, it's denser, it's heavier. And so it's going to go underneath the yellow plate, and subsequently create a landform and force up this topographic feature. And so previously we had two flat areas that are now we have a rugged area as the pink plate has lifted and forced up the yellow plate.